Vanakkam. Welcome to this course on classics in neuroscience. We've been looking at classic Nobel Prize winning works in the field of neuroscience. In this series, we've been looking at the classic Nobel Prize winning works of Santiago Ramon y Cajal. In this video, we will summarize the contributions of Cajal that led to the award of Nobel Prize in Physiology and Medicine in the year 1906. What are all the things that he did? Essentially a summary of the previous few videos, or maybe a little bit of new additions, but essentially a summary, a synthesis of his work. This body of work is just so much that it is useful to repeat and summarize every once in a while, otherwise you will forget. So, this is essentially a summary video. So, the Nobel Prize 1906 was awarded along with, shockingly, along with Camillo Golgi. The Nobel Prize in Physiology or Medicine in the year 1906 was given to Santiago Ramon y Cajal, shared with Camillo Golgi. Cajal was the first Spanish scientist to be awarded the Nobel Prize. Why did he win the Nobel Prize? Because he showed that neurons are independent functional units. He established the independence of neurons. He practically discovered the structure of synapses, although the term synapse itself was coined by a different scientist, also a Nobel laureate whose works we will see in maybe next week, was also a colleague and maybe even a friend of Cajal's. We will discuss that anecdote at some point, and essentially improved the study of nervous system anatomy in a very big way. Shockingly and ironically, Golgi in his Nobel lecture attacked Cajal's view of the independence of neurons, and he continued to maintain that the nervous system and the cells of the nervous system essentially formed part of a fine network or a net or a reticulum. But Cajal used his Nobel lecture to defend the neuron doctrine. So, but Cajal himself did not attack the reticular theory, he just provided evidence to his own work. But Golgi attacked the independence of neuron or the neuron doctrine in a very big way. The neuron doctrine essentially is a Nobel Prize winning breakthrough in neuroscience that established that the nervous system is composed of discrete, individual, separate, independent neurons. Cajal famously said that the neurons are in touch, but they do not touch each other. It is like this: if you consider my right hand as a neuron and the left hand as a neuron, they are very close to each other. They are in touch with each other, they communicate with each other. Exactly how this communication happens is a matter of research that was established later. We will discuss that also as part of our Nobel laureate winning works. But he said that, let us say these two hands are neurons, they are in touch with each other, but they do not touch each other. That they do not touch, two neurons are discrete, but they communicate with each other. Exactly how that communication happens will be established later. So, this is his famous statement: the neurons are in touch, but they do not touch each other. Original contribution by Santiago Ramon y Cajal in the 1880s and 1890s, essentially putting to rest the reticular theory that neurons formed a continuous network. This idea that the central nervous system or the nervous system itself is composed of individual, separated, independent, discrete neurons laid the foundation of modern neuroscience, practically leading to the idea that it was the network features of the neurons that are more relevant, that are more valuable rather than the connections themselves. The idea that how neurons communicate with each other and how do they form networks and the kind of communications that happen between them essentially defines the experiences, the decisions, the perceptions the organism takes or goes through. This essentially laid the foundation of modern neuroscience, influencing practically everything in brain research, even in artificial intelligence. Before the neuron theory, the reticular theory was popular. There are no separate neurons or independent neurons. Camillo Golgi developed the Golgi staining techniques which allowed visualization of neurons, but it was Santiago Ramon y Cajal's double impregnation and improved Golgi method that led to different interpretations of the same observations. Essentially the same observation, but interpretations are different. Showed that neurons were distinct, independent, individual, separate, functional units with the gaps between them. These gaps were called as synapses, although he himself did not name the synapse. So, for this contribution, he won the 1906 Nobel Prize, which he shared with Camillo Golgi. Already mentioned this several times, neurons are distinct and structurally independent. They are the fundamental building blocks of the entire nervous system. Information flows in one direction, from the dendrite to the soma to the axon to the synapse. Neurons communicate via synapses, not direct physical contacts or connections. Each neuron acts as an independent metabolic and genetic unit. This supporting evidence for the neuron doctrine came from the drawings of Santiago Ramon y Cajal that showed individual neurons with gaps between them, but decisive evidence was to come only 50 years later, or even more than 50 years from the time Cajal theorized this. When Cajal theorized this, it was 1889, 1890, 1891. About 60 years later is when the electron microscopy became popular, and it confirmed the presence of synapses and the presence of gaps between the neurons. Further, electrophysiology studies demonstrated action potentials in single neurons and also delays between neuron communication, showing that why if the communication is purely electrical, that is happening within a single neuron, because the other neuron is also part of the same network, you won't actually have delays. If there is a delay, that means between two neurons that are communicating with each other, there must be a gap. This gap is what is causing the delay. That delay is called a synaptic delay. And also later, fluorescent labeling techniques helped scientists to visualize synaptic activity in real time. Also, law of dynamic polarization that Cajal proposed, that information flows in a particular direction and flows from dendrite to soma to axons to synapses. But then there were some exceptions later, much later. It was found that there are some sort of back propagation that happens in dendrites. Of course, refinements to the neuron doctrine continued because there were new discoveries. Dendritic spines contribute to synaptic plasticity was something that was discovered much later. Sometimes there was also axonal synapses that happened and dendritic synapses that happened. These were exceptions, not the rule, but these were also there in the system. For the longest time, glial cells were thought to be of just provide myelination and had no practical value in neurotransmission, but then now it is established that glial cells also play a critical role in neurotransmission, and electrical synapses are exceptions to the rule. For example, in some cases there are gap junctions, that is gaps or junctions at which point two neurons can exchange material, cytoplasmic material between each other. So, this is essentially like the reticular theory. but this is not the exception, not the rule. This is present only in certain regions of the brain and in the heart, excitable cells. So, he proposed the growth cone. He essentially studied that the growth of embryos. He documented the structure of the growth of neurons over a period of time. He was one of the first scientists to propose that the brain is capable of changing and adapting throughout its life. That is how we learn things. He suggested that neurons can form new connections in response to learning and experience. It is a brilliant insight to make in the 1890s. This is what we call today as synaptic plasticity. He also theorized that damaged neurons could reorganize themselves, forming alternative pathways to bypass injury. Again, a critical insight for someone to make in 1890s. Now, today this is an accepted theory. One of the earliest description of neural plasticity. Today, neuroplasticity based approaches to neuro rehab dominate the field of rehab. There is now a major area of research in learning, memory, rehab everywhere. His ideas influenced modern therapies for brain injury, stroke recovery and neurodegenerative diseases and everything, practically all the fields. So, his theories continue to inspire many generations of scientists like cognitive neuroscience, AI based learning algorithms. He anticipated modern rehab therapies for stroke and traumatic brain injuries. Incredible. So, with this we come to the end of this video. In this video, we looked at a summary of the major contributions of Santiago Ramon y Cajal that led to the award of the Nobel Prize in Physiology or Medicine 1906 that he ironically shared with Camillo Golgi. With this, we end this lecture. Thank you for your attention.